Okay, morning. Hopefully your morning is going better than mine. This is now try number 3 at recording. This has been fun today. But anyways, hope everybody's had a good new year. Hopefully 2020 gets past us as soon as possible. All right, so here we go. Which element forms an ion that is larger than its atom? So looking at this, you have positive ions and negative ions, generically speaking. A positive ion is an ion that will lose electrons when it forms from its atom, and a negative ion is an ion that will gain electrons when it forms an ion from its atom. So if you're looking here at calcium with a +2, that means it lost 2 electrons. If it loses electrons, the thing's going to get smaller. So the atom has, for calcium, the atom has 20 electrons. All right, it forms a +2 ion, so it's going to go down to 18 electrons. So it goes from 20 to 18. So since it loses electrons, it's going to get smaller. Aluminum is going to get smaller because it's losing 3 electrons. Chlorine, because it's a -1, is gaining an electron, which means it's getting bigger. And then hydrogen +1 is losing 1 electron, so it's getting smaller. So the only one that forms an ion that's larger than its atom would be chlorine. So that would be your answer here. Okay, test is Wednesday. It's on testwizard.com. Just like they always are. The window to take it is from 11:30 a.m. to 12:45 p.m. That's 75 minutes. You only get 60 minutes to take the test. All right. So somewhere within that 75-minute window, you need to complete the test. All right. 11:30, nobody has class because that's the lunch time, shall we say. And then 12:45 would go on to your 4th block class for the day, or whatever class. I think social studies is after us on Wednesdays. So you have an hour to do it. So don't log in at 12 o'clock and expect to get an hour, because that won't work. It's going to time out at 12:45. You can't go past 12:45, but if you do want to start it before 11:45, then you have the option to do so. Okay. But ultimately we have 11:45 to 12:45. So you have that 1 hour time to be able to do the test. Time will be a factor. You will not be able to look up every answer. You'll not be able to text people and things like that. So just make sure you're working quickly through there. People are saying, "Oh, I just didn't have time to finish it." That's not acceptable. You have to finish this test, or it'll be graded as 0 for whatever you don't complete. All right. This material can be done, or the test is written so that it can be completed in the time frame, but you have to know the material. It's kind of like you're taking the test in a class where you're not looking anything up. You're just, other than using your reference tables. That's all you have the ability to do. All right. And the time it takes to look things up slows you down. It allows you not to finish things. So that's the test. Today we're going to be reviewing for the test, basically wrapping up. There's no new material necessarily in this lesson about the periodic table, but it's a good review of things. So here we go. All right. So periodic table of elements. So here you go. You got your periodic table right here. Actually, I think I'm going to pop this down. I'm going to do this the old school way to make sure that life works out well for us here. So here we've got, this is your periodic table that you have on your reference tables. And this one's going to allow me to write on it, is kind of why. Okay, so looking here, all right, so you've got groups that go top to bottom, and you've got periods that go side to side. All right, there are 18 groups. You can see the numbers on the top. All right, and there are 7 periods. Now remember, being in the group means you have similar chemical properties because they have the same number of valence electrons. All right, with the exception of, I'm just going to kind of put this right here. All right, we'll talk about what these are. All right, or review what these are, but this I call the gobbledygook. All right, the valence electron rule doesn't necessarily apply for them, but it applies for all of what we would call the tall groups. All right, so elements in the same group are going to have the same number of valence electrons, which means they're going to have some similar properties. Elements in the same period, all right, do not necessarily have the same properties. All right, the only thing that they have in common is they have the same number of energy levels. Elements in period 1 have 1 energy level, period 4 have 4 energy levels, period 7 have 7 energy levels. That's really all that they have in common. That's it. Okay, so if you remember, group 1 is called the alkali metals. All right, remember, alkali metals are the most reactive metals on the periodic table. They have 1 valence electron. They will lose them very easily. And if you remember, this element down here will lose it the easiest because it's got its valence electron the farthest away. So it would, and ultimately would be the most reactive metal on the periodic table. And that element Fr is francium. I'm trying to get this in focus. It doesn't look in focus to me on the screen, but I think that's the best I'm going to be able to do. Sorry to try. Hopefully we really don't need to see the small numbers on there. You just need to see the letters. So we're good. Okay, so alkaline metals, most reactive metals. Group 2, alkaline earths. All right, they're still reactive metals. They're not nearly as reactive as group 1. You can't go dig up a chunk of magnesium. All right, it's going to be bound as a compound in the Earth's crust or whatever, or any of these elements in here. So they're still reactive, but not as reactive as group 1. All right, these 3 through 12, I call the gobbledygook. These are called transition metals. All right, these are the things that you would think of as being metals. All right, silver, gold, copper, zinc, platinum, all right, those things, iron, okay? All right, they would have the 5 metallic properties. They conduct heat, conduct electricity. They have luster, or they're shiny, malleable, and they're ductile. All right, another unique thing about transition metals is they form colored solutions. All right, when dissolved into water, these ions will make colored solutions in all kinds of different colors. It's kind of cool. It's kind of one of the ways that you identify it as a transition metal. Okay, all right, group 13 really doesn't have a common name for it. All right, it's called the boron group. 14 is carbon group, then nitrogen, and then oxygen. Remember, this zigzaggy line is the divider between metals and nonmetals. To the left, you have metals. To the right, you have nonmetals. Remember the elements touching the zigzag line. I'm going to circle them right here. Or actually, I should not have circled aluminum, sorry. Boron, silicon, germanium. All right, these are the ones I circled are the metalloids. All right, but you can circle polonium and astatine. It doesn't really matter. There's not enough on the planet to worry about. But the things whose sides touch the staircase have some of those 5 properties of metals and some of the properties of nonmetals. Okay? Group 17 are called the halogens. All right, they're called the halogens. They are the group that's the most reactive nonmetals. All right, remember nonmetals will have the ones with higher electronegativity will react more vigorously. So as a result, fluorine, because it has it's the highest electronegative element on the periodic table, would be the most reactive nonmetal, and then the reactivity goes down from there. All right, group 18 are called the noble gases. They are not reactive. They're stable, or inert is the word that chemistry people like to use. I don't know why. All right, they're inert because they have full valence shells of electrons. They don't need any electrons. They won't lose the electrons, so they stay kind of by themselves. So they're inert. They don't like to react with other things. Okay? All right, so those are your transition metals on there, or transition metals. That's kind of a quick group name summary of these things. Let's go on. Do you guys remember diatomic elements? Diatomic elements, remember there's 7 of them. All right, if we color them in on here, all right, which is sometimes helpful to do it. All right, so these ones, hydrogen is a diatomic, oxygen, nitrogen, fluorine, chlorine, bromine, iodine. So see how it makes kind of a 7, and then you got the hydrogen hanging over there. So remember the 7 diatomics, you have the mnemonic for it. Let's see if I can get this in here so you can see. Yeah, you can still see it. It's HON 17. HON 17 means hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. Notice I wrote them all with a subscript 2. All right, if they ask for the symbol for the diatomics, you have to write it as a subscript 2. That is important. It's going to be of utmost importance in the next unit. But for now, that it is what it is. If they ask you just the names, and you just give the names. It depends on what the question asks. Okay. The other mnemonic for it is Brinkelhoff. Do you remember Brinkelhoff? B-R-I-N-C-O-H-O-F. Basically, the first letters of all the elements. There's have no fear of ice cold beer as well. That's more important for next unit, but I will guarantee you it's going to be on the test on Wednesday. All right. So make sure you know them. All right. Dot diagrams. Oh, actually, before we get to dot diagrams, I wanted to talk about phases of matter on the periodic table. All right, the majority of the elements, the metals, are solids. All right, there are two liquids on the periodic table, and I'm going to circle them. All right, one liquid at room temperature at STP is mercury. All right, that's a liquid at room temperature. It's the only liquid metal. The only liquid nonmetal is bromine. All right, so bromine is a liquid nonmetal. So those are the only two liquids at STP on the periodic table. All right, the other ones you want to know are gases. Obviously, the noble gases are all gases, so I'm going to circle all those in red. All right, and sorry, this one is not named. It doesn't matter. Well, according to this one, it's not. So those are all gases. And then also at room temperature, gases are chlorine, fluorine, oxygen, nitrogen, and all right, those are all gases at room temperature. So everything that we didn't circle is a solid. So the vast majority of the elements on the periodic table are solids. Okay? All right, so now we go back here. Dot diagram, just quick review. If you were to make the dot diagram for a nitrogen atom, so you got nitrogen atom. So a nitrogen atom, start off with its symbol is N. You look on the periodic table, it's colored in red, but it's got 5 valence electrons. So that means it's got to have 5 dots around it. All right, and remember they fill in that form. All right, nitrogen ion. All right, if we look at the periodic table, for nitrogen, its top charge would be -3. So if you're still going to have a symbol of N, you got to put the -3 charge. And because it's an ion, we need brackets. All right, and it's got a -3 charge. So what that means is you're going to start off with your original 5, and then it's going to pick up 3. And notice it conveniently fills in all of those spaces in there. So this is kind of similar for all negative ions. They're all going to have 8 valence electrons, or 8 dots around them. All right, we'll do a calcium atom. So calcium is right here. All right, its symbol is Ca. All right, we look at the number of valence electrons it has 2. So we're going to put 2 up there. All right, now we'll do a calcium ion. All right, so we start off with its symbol. We know it's going to have a charge, so we look here, calcium is going to form a +2 charge. Since it's an ion, we do need brackets. All right, now because it's +2, normally it would have 2 electrons, but it lost those 2 electrons. Okay, so what some people think that they do, if you look at the configuration for calcium atom on the periodic table, it's 28882. All right, so if it loses these 2 valence electrons, a lot of people try to draw 8 valence electrons in here. Don't do that. Its valence shell is the 4th shell, and now when it loses 2, it's got 0. So this is the correct dot diagram for a calcium ion. When you get to ions, generally speaking, you're going to have either 8 or you're going to have 0 dots. You just have to figure out which one it is. And positive ions are going to have 0, negative ions are going to have 8. Okay? All right, so now we're going to talk about trends. All right, so now we're going to talk about trends. I'm going to grab a clean periodic table. All right, we're going to have trends as a group and trends as a period. Remember, groups go top to bottom, periods go side to side. All right, the one trend we're going to talk about, I'm just going to overwrite on this. I apologize. This is the issue that I have with this. Recording before I can do it electronically. So size. So we're going to have a trend that goes across a period, and we're going to have a trend that goes down a group. All right, and we're going to do the same thing for electron. We'll just do size right now. We'll talk about it as we go. So size, as you go across the period, the size of the atom gets smaller. Or you can see. All right. As you go down a group, and it gets smaller because there's more protons pulling it in. This one's got 9 protons versus 2 or 3. It can pull them in tighter. As you go down a group, it does have more protons, so you would think it would get smaller. But what's the overlying factor is that it has more energy levels. So if you go down a group, they actually get larger. The elements actually get bigger. If you remember in class or in the notes, I gave you the snowman analogy, or the person who tipped over the snowman. Okay, so the size, as you go across the period, it gets smaller. As you go down, it gets larger. Okay, electronegativity, I'm going to abbreviate electronegativity as EN. Remember, electronegativity is the ability to take an electron from something else. And we're going to have the trend as you go across the period. All right, as you go across the period, the electronegativity generally increases. All right, with the exception of group 18. Group 18 has no electronegativity because they don't want to gain any electrons. Okay, and if you look on your table S, it's not even going to have a value for electronegativity for those. So generally, they're going to increase, and as you go down a group, electronegativity is going to decrease. All right, fluorine here has got the highest electronegativity. So think of it as you go work towards fluorine, it gets bigger. As you go down from fluorine, it gets smaller. That's the trend for electronegativity. Okay, fluorine is the smallest atom that's going to want electrons. So it has the most electronegative ability. All right, ionization energy, I'm going to abbreviate IE. Ionization energy is the ability to hold on to your own valence electrons. Okay, and we're going to do the trend across and the trend down. All right, so if you think about it, as we go across, the atoms get smaller, right? So that means the electrons are getting held in tighter, so it's going to be harder to remove the electronegativity or the outermost electron. So ionization energy will increase as you go across a period. All right, as you go down a group, they get bigger. All right, so since they get bigger, it's going to be easier to remove an electron, so the ionization energy gets smaller. The energy needed to remove an electron gets smaller. Francium has the lowest ionization energy, all right, which means it's the most reactive metal, all right, or the most metallic properties. Okay, so there's those three. Then we're going to talk about metallic character. As you go across the period and down a group. All right, as you go across the period, the metallic character. If you think about these things here, I'll write it in different colors, so it's not. Generally, you have metals here, and generally over here, nonmetals. All right, so as you go across the period, think about it, metals to nonmetals, that's a decrease in metallic character. So as you go across it, it's going to decrease. All right, and as you go down a group, now you can't look at these groups over here because all you have is metals. Come over to a group that's got both nonmetals and metals. So this one, as you go down a group, it goes from nonmetals to metals. So metallic character increases. That's just an easy way to figure out the trend. The reason is metallic character, you determine the metallic character by low ionization energy. All right, the elements with lower ionization energies are going to have more metallic character. Okay, let's see here. So we did group ones lose. All right, so group 1 elements generally lose 1 electron because they have 1 valence electron. Group 17 generally gain 1 electron. All right, that's why they're -1 ions. We did states of matter already. Most reactive metal on the periodic table is francium because it's got the lowest ionization energy. Most reactive nonmetal is fluorine because it's got the highest electronegativity. Remember, nonmetals have higher valence electrons, so they're going to gain electrons. Metals have lower valence electrons, so they're going to lose electrons. Okay, so I think that's it with the periodic table stuff. All right, so now I'm going to go back to here, and I'm just going to click through a couple slides so that we don't have to worry about those. All right, so here we go, synchronous learning. All right, we got our big change going on here. All right, we're starting it this Thursday, the day after the test, with us meeting for a few minutes each time you have class. So it's beginning January 7th. Right now, I think I'm going to do it on Google Meet. That could change if something comes up. But right now, we're going to go Google Meet. I was told by you and others that it's easier for students to get into Google Meet than Zoom. Okay, so we'll try that. If it doesn't work out well, we'll flip to Zoom. But kind of like everything this year, we're kind of adjusting on the fly. But a couple things. Block 1 is at 8 a.m. Block 2 is at 9:30. Block 3 is at 11. Let's see if I can just present this. Sorry. I don't know what that big circle is. That's weird. All right, so block 1's at 8 a.m. Block 2 is at 9:30 a.m. Block 3 is at 11 a.m. And block 4 is at 1 p.m. It's imperative you get in by this time. All right, I will open them up before. All right, but don't show up late. We're only going to be there. Some days we might only be there 5 minutes. All right, and if you don't show up on time, you're not there. It doesn't count. All right, right now this is the time I think that will work for both when we're remote, completely remote, and then when we're hybrid. If I might have to adjust the times once we get back into class where we have some kids in class, but right now we'll go 8, 9:30, 11, and 1. All right. The important thing is we're only going to meet on our quote unquote class day, not our lab day. All right. So you have to follow your class schedule. So, we'll meet once as a class on Monday or Tuesday. Wednesday, you'll have your test or quiz like normal. And then we'll meet once as a class on Thursday or Friday, depending on what the schedule of the classes are those given days. All right. Block 1 and 3, you're going to meet on AC days. All right, because that's how our schedule works. You have gym on either B or D day, depending on which one you have. I don't know. All right, in blocks 2 and 4, we're going to meet on BD days. All right, I'm trying to make life as easy as possible for you. I don't want to eat up your time, but I have my requirements that I have to do. If I learn that this works out well and people want to meet on the lab days, then that by all means we'll still do that, or we can add that. But right now we're just going to go with the class days. All right, so understand the difference between a class day and a lab day. All right, and normally we don't distinguish between this and during the school year. All right, but you have your normal, whether you're an AC class or a BD class. All right, so block 1, you're going to meet at 8 a.m. on an AC day. Block 2, you're going to meet at 9:30 a.m. on a BD day. Block 3, 11 a.m. on an AC day, and block 4, 1 p.m. on a BD day. Okay, all right. Requirements. What's going to be expected of you? Obviously, to be on time. All right. You must have your camera on you, not the ceiling, not the floor, not the wall. All right. Have to see your face. Okay. To know that it's you. All right. Obviously, you should be attentive on there. You will miss information if you don't attend. It's not really going to be chemistry information per se. It could be though, because it could be stuff that we go over things on. All right, but you will miss information if you don't attend. If you show up late, you miss it. It's literally that simple. All right, and then 10 to 15 minutes is probably the time frame that I think is going to be necessary. If we need longer, we'll be longer. All right, so I just don't know. It's going to be on a given day. If you want to stay longer, you're welcome to, and I can answer questions. We can go over things. All right, but for the whole group, it's going to be determined by me how long you're there. Okay, and it's going to change from day to day, but I will try to keep it as minimal as possible because you still are going to have your Edpuzzle stuff to do and your lab stuff to do and your work stuff to do. So I don't want to eat up the whole time with whatever doing the synchronous learning stuff. You still have your asynchronous stuff that you have to do. The synchronous stuff is just for us to kind of meet and kind of if there's issues, if I screw up something, I want to get something correction to you or whatever. All right, and a lot of it's going to be homework. All right, going over homework. So now you have to have homework done on time. All right, so that you have it done so you can see what you did. Okay? All right. I think that's it. All righty, have a good day.